All right, if you're a software engineer, you just know a Git question is coming up in your technical interviews. It's practically a given. So today, we're going to get you ready with the kind of clear, confident answers that hiring managers are really looking for. We'll start with one of the most common ones out there.
Okay, picture this. You're in the hot seat. The interview is going great, and then, boom, they hit you with this question. It's a classic, right? And it's designed to see if you actually understand version control in the real world. How you answer this can honestly make all the difference.
But hey, don't sweat it. We've totally got your back. We're going to break this down piece by piece so you can walk into that room and answer this and any follow-ups they have with absolute confidence.
First things first, let's get right to the heart of that interview question, fetch versus pull. Now, they're both about getting updates from a remote repository, like GitHub, but they go about it in two fundamentally different ways.
The easiest way to think about this is that Git fetch is kind of a safe look but don't touch deal. You download all the new information, but you don't automatically apply it to your work. Git pull, on the other hand, that's the whole shebang. It downloads and immediately tries to merge those changes right into what you're doing.
Let's zoom in on git fetch for a second. When you run this command, Git just goes out to the remote server and downloads any new commits that you don't have yet. But, and this is the crucial part, it doesn't touch your current working files at all. It's like getting the latest newspaper delivered and just leaving it on your doorstep. You can read it whenever you're ready.
So, for example, when you run git fetch origin, you're just updating your local machine's knowledge of what's happening on the remote. Your remote tracking branches, like origin/main, get all the new info, but your local main branch is left completely untouched. This is great because it gives you a chance to look at the changes before you decide to merge them in.
And now for git pull. This is the more direct, get-it-done-now approach. You can think of it as a 2-for-1 special. What's really happening under the hood is that git pull runs a git fetch first, and then, without even pausing, it immediately tries to run a git merge to integrate those fresh changes right into the branch you're working on.
So yeah, the single most important thing to remember is that git pull is a compound command. When you type git pull origin main, you're basically telling Git, hey, go get the absolute latest from the main branch on the remote and merge it into my current local branch right this second. It's fast, for sure, but you lose that moment to review things first.
Okay, so that merge component we just talked about, that brings us to the next critical topic and a classic follow-up question. How do you combine your work? The two main ways are merging and rebasing.
And right here, you see a core philosophical difference. Merging is all about preserving history exactly as it happened. You see all the branches, all the twists and turns. Rebasing, on the other hand, is about cleaning up that history, making it look like everything happened in one single, clean, straight line.
When you use git merge, you're telling Git to take two separate lines of work and literally tie them together with a brand new special commit. This merge commit is unique because it has two parents, one from each branch, and it stands as a permanent record that a merge happened right at that point.
Let's actually visualize this. Imagine the main branch has moved forward with a new commit, C. At the exact same time, you've been busy working on your feature branch, adding your own commits, D and E. Now, as you can see, your histories have diverged.
So, when you merge main into your feature branch, Git creates this new commit, which we're calling M. This special merge commit neatly ties the two histories of C and E together, creating a complete and totally accurate record of what actually happened.
So, the big win for merging is historical accuracy. You can look back and see exactly when and how work was combined. The downside? Well, on a busy project, your Git log can start to look like a tangled subway map with all those extra merge commits.
Okay, now for the alternative, Git rebase. Instead of tying two histories together with a knot, rebase actually rewrites your branch's history. It takes your commits and replays them, one by one, on top of the other branch. What you get is a beautiful, clean, linear history. We're starting from the exact same situation as before. Main has that new commit C, and your feature branch has D and E. The history has clearly diverged. But wow, look at the result after a rebase. Instead of a merge commit, your commits D and E have been lifted and placed after C. They become D' and E' because, while they contain the same changes, they're technically brand new commits. The result is a perfectly straight, linear history.
The appeal is pretty obvious. You get this super clean, easy-to-follow history. But, and this is a really big but, you are rewriting history.
Because of this, you should never, ever, ever rebase a branch that other people are also working on. It can cause serious, serious headaches for the rest of your team.
So how do we actually use these commands in the real world? This is where theory meets practice. Let's walk through a very common strategy that teams use to get the best of both worlds, a stable main branch and really clean feature histories. This is a fantastic daily routine to get into. First, you switch over to your local main branch. Then you pull the latest changes from the server so you're totally up to date. After that, you switch back to your feature branch. And for the final move, you rebase your feature branch on top of that now updated main. This integrates all the latest updates into your work while keeping your commit history clean and linear before you push.
All right, we've covered a ton of ground, so let's lock in all these concepts with a final cheat sheet. Think of this as your key to a confident interview answer.
This table puts it all together. Just notice that fetch is the only command here that doesn't change your local branch. It just downloads info. Pull and merge do change your branch, but they always preserve history. And then rebase is the unique one. It both changes your branch and rewrites his history to get that clean, linear look. Ultimately, it all comes down to this one strategic choice. And honestly, there's no single right answer. It's really about your team's philosophy. Does your team value a complete, unaltered historical record, almost like an audit trail? Then merge is your best friend. Or do you prioritize a clean, linear, easy-to-read story of how a feature was built? Then rebase is the tool for the job. You just have to remember to use it with caution on your own branches.
So now you're equipped. You're not just ready to answer the question, but to really understand the strategy and the trade-offs behind it. So the real question for you is, in your own work, which path will you choose? Because thinking about the why behind your commands, not just the how, is what separates a good engineer from a truly great one.